Hello guys, and welcome back to another video of Daniel's Security Academy. Today we are talking about mobile first architecture, mobile first network architecture. I'm going to tell you what is it about, what do you need to do this, and what are pretty much the advantages and disadvantages of those new concept, pretty much. Okay, but first of all, I want to give you a small intro. So what is the scenario? Where does the mobile first architecture come from? Why does it arise in the past years? Where is a simple reason for that? So the way of working and therefore the way of connecting changed in the past year as companies adopting new office concepts to make better use of the office space and increase attractivity to the offices. As you know, COVID happened, so people were moving to the home office more frequently or almost primarily, and therefore the need for office space decreased, and it pretty much gave the offices a new use case. You could use the space you have in a different way because you have to accompany less people on the same space. So additionally, sustainability became an integral part of investments, as well as having flexibility and scalability at the same time. So the last years, everyone is talking about global warming, about being more sustainable with the resources we have on this planet. And this kind of movement we see also in a political way, we do see in enterprises as well, where enterprises try to be more sustainable with their resources. Mobile first is an enterprise architecture approach that reduces the amount of hardware needed, as well as streamlines the user experience with the network connection. Mobile first, to not talk too much about what it is, will help users, especially non-IT users, to have it easier in the company to connect to the network and have a familiar look and feel than they have it from home. And this is based on everyone at home has a Wi-Fi connection. Therefore, it also makes sense to use Wi-Fi in the enterprise because the user already knows what to click on the phone, on a computer to connect to a Wi-Fi. But this is just a small part of it. This approach is capable of providing the required flexibility, scalability, and sustainability of offices without sacrificing any kind of quality or security. I already hear your voices saying okay, Wi-Fi is not as reliable as cable Ethernet. And you might be somewhat right, but you might be surprised about the changes we had in the past years. So let's give it a shot. What is mobile first? What is the term about? I just gave you the introduction about how the scenario is looking like and maybe where or how we came to the approach of mobile first. But now I want to tell you about what is mobile first. Mobile first in itself is not a firmly defined term in the field of network architecture, but it can be broken down to a few key points. It describes a basic approach that end devices in a network primarily connect via a mobile or wireless connection, like Wi-Fi maybe, or could be also cellular. So you could also make use of 5G. However, a little heads up here already, 5G in modern offices can be difficult, especially if you're going to countries which have highly insulated windows, for example, which block most of the radios for 5G, which leads to the fact that your phone has barely any 5G coverage inside the building. So this 5G approach over Wi-Fi definitely needs to be considered depending on the building, per building pretty much. Anyway, I got carried away a little bit here. Network architecture changes can be seen regularly in the course of the years in enterprises. So whether it's a shift from centralized to decentralized networks, or it's the heavy use of cloud technologies and outsourcing workloads to the cloud, these paradigm shifts take place because requirements or prerequisites have changed. So why hasn't the mobile first approach been more widely discussed and used, especially also by vendors? Because we did a lot of changes. So requirements and prerequisites changed in the past years. But I will get to this in a second. A few years ago, mobile connections were still considered unsecure, unstable, not performant enough. But with Wi-Fi 6 and 5G, however, the state of the prerequisites is changing dramatically. Like, mobile technologies are now very much more reliable, performant, and secure to use. So why still rely on expensive network hardware and complex building cabling when tomorrow's workplaces will operate on a maybe open space concept or even remote working principle? And the Wi-Fi, or let's say the mobile first approach, gives you a better scalability compared to regular cabling, because you don't need to cable every single work spot. You just have a Wi-Fi coverage for the entire building or the entire floor. Let's talk about the basic setup of mobile first. What do we need? Well, it's pretty simple and straightforward. You need access points, and you somehow need a controller of those access points, preferably in the cloud. Why do I want it in the cloud? Because cloud solutions usually give you the most flexibility and scalability. Relying on a hardware or software fixed Wi-Fi controller, which can support you 50, 100, 250 access points, whatever the limitations are, it will not give you the flexibility and scalability you need. Because you, as a company, as an enterprise growing this approach, you wanted to adapt quickly without having to rethink, does my Wi-Fi controller still support a number of access points? How do I connect this new location to the Wi-Fi controller? Because if it's in the cloud, you just simply need an internet connect. And let's be honest, by now, 2022, companies should at least one internet-based access on site on an office. So if you're still on an MPLS running inside your enterprise network, that's okay, but at least have one DSL cable, cellular, whatever, connection to the office where you can break out internet traffic locally without backhauling it to a data center. Of course, we need to be clear here, we also need some switches for this setup. It's not like you can get rid of any switch, because you somehow need to connect all those access points to the network or make it a network, and you have to power them. So you will need some switches with power over Ethernet capabilities. So you have some switches, maybe make use of 48 port switches if you have the capabilities of wiring all access points to them, or make use of 24 port switches if you have less access points and you cannot connect those to the same switches. So very customized how you should do the switch situation based on your office. Then you will need a well-organized Wi-Fi coverage. So if you rely on mobile first as your network connection architecture, you need to make sure that you have Wi-Fi connection or coverage everywhere you need it. So just hanging up an access point on the ceiling or somewhere on the wall is not a good approach. Pay someone external to do a Wi-Fi coverage analysis and let them tell you how many access points do you need, where do you need to place them. This will save you a lot of trouble and money for sure. Fourth, we need some, or we don't necessarily need them, but I highly recommend using some analytics functions which you can use to find bottlenecks and kind of improvements. Maybe even generate a heat map to see, okay, my employees are frequently around this meeting room, and we do see some bottlenecking coming from this access point because there are too many devices streaming too much data from there. Maybe we should get either another access point there or a better access point which can do more than 1 gigabit, for example. And those insights and troubleshooting capabilities you will mostly get with some kind of analytics functions. I don't want to call out any products, names, technologies, because this can be a broad term. Whatever Wi-Fi solution you use, you will most likely be able to get some analytics functions from them. Lastly, for the basic setup, you need to do a network architecture diagram. But this is probably a no-brainer, right? So write down or draw the architecture itself, like your firewall or your router, which is on the WAN, then maybe your core switches, if you're big enough, have a big enough campus to need the use of core switches, or your regular switches, and then see which access points you can connect to which switches, how many switches do you need actually, and yeah, just make sure to follow the 100-meter rule for copper Ethernet for the access points, because you want to use copper so you can transport the electricity, the power I mean, to the access points. You don't have to power it up locally with an adapter, for example. So those are those kind of thoughts you need to put into the overall network architecture diagram. Is it the wireless future of offices? Is mobile first the architecture to change the game? Let's start with talking about different use cases. One use case is, for example, a retailer. A retailer has many small locations with a very predefined set of hardware in there, and those retailers usually have a very similar overall size and structure. So it is a very replicable scenario, which is mostly covered with Wi-Fi, because those retailers offer customers a free Wi-Fi service. So Wi-Fi is already in the house. So why do you need switches over there to cable something? Well, you might need one switch to cable some of your cashier devices. You might need the switches or a switch to connect the access points. But cabling everything inside a retailing shop doesn't make sense. And to be honest, today they already do mostly Wi-Fi stuff. So if, for example, employees are running around the shop using a tablet, they already use Wi-Fi to maybe check the stock or check if something is in stock. So yeah, this is already a scenario where mobile first is somewhat already used already, but by the nature of the scenario or the use case itself. The second one is an office-based company. That could be anything. Could be like a software development company. I don't know. There are multiple branches where you will have a less amount of offices, but those offices are bigger, maybe 3 floors, 4 floors, bigger buildings. And those enterprises usually have some guests, so they offer guest Wi-Fi. Maybe they even offer Wi-Fi to their employees for their bring your own device devices. Or they most certainly offer those Wi-Fi because they also offer Wi-Fi to company devices like laptops. If an employee is moving from his workplace to a meeting room, for example. And those offices or this use case is especially affected by the changes COVID is having to the way we are using offices. And those have already been adapting, maybe even before COVID, the concept of open space. Not every employee has a fixed location where he's sitting, and he maybe just have like a container which you can use to store personal stuff, and he just sits wherever it's where a seat is available, right? The coverage of an open space office is usually fairly easy. It is harder to cable stuff if you have very mobile workplaces, or you are frequently changing the layout, and you don't have to rely on the tanks on the floor anymore, where you have cable connections to put a cable from the floor tank to your desk. No, for the open space you can just use the Wi-Fi to cover all the workplaces with 1, 2, 3, depending on how big it is, of access points. Usually those open space offices or concepts don't have walls, so the coverage is very, very good with already one access point, because you don't have to get through some kind of metal, wood or something else of material, whatever's in the wall, to cover all the rooms. So this is especially good use case for mobile first. Third use case I see is, for example, a logistics company. Most part of the company is working remote from somewhere. So people working from customer sites, they are working from home office, they are working on the road. And those will not be able to have the same kind of Wi-Fi coverage everywhere they are, because on home there's their own Wi-Fi coverage. At the customer side, they have customer Wi-Fi, but not necessarily there's guest Wi-Fi available. So for those persons and for this kind of use case, we actually do see the use of cellular, so 5G, as a very good way of connecting those people to the network and the internet. So, for example, if a roadrunner, whoever works remote, home office, customer side, on the road actually. Just give him a SIM card to his laptop, and he just connects whenever he's working via the SIM card. He doesn't need to bother about finding a Wi-Fi that has enough performance. No, just with the 5G, he has the same kind of working wherever they are. They just open up the laptop, SIM is connecting to the mobile network, bam, connection up. Then you might just run a VPN connection to connect to a data center, whatever, to a corporate enterprise resources, but it's always the same way of connecting for the user. And it might sound a little bit silly, but for people who are not IT focused, non-IT persons, it will help them to have the same kind of connection every time, something they can remember by heart. And this will save you as administrators or engineers in the back end tickets maybe from users, because everything looks familiar. They don't have to open a ticket. Oh, this one is looking strange. What do I have to click? So it might be even for you reducing overhead. So let's talk about advantages and disadvantages of this architecture, because we need to be honest. There's not everything is brutally perfect, right? There is also disadvantages to this kind of approach, but those disadvantages might not apply to you. They might apply to a different company. Okay, let's talk about the advantages. First advantage is you are going to reduce your hardware footprint drastically, because you can get rid of many switches. So instead of having 200 workplaces connected with wires, making it probably you have 7, 8, 9, 10 switches for this, you can get rid of at least the half of those switches. Probably you will be fine with one switch per floor, which will power up your access points and will maybe connect, for example, if you have door opener, which require a cable connection, because there's some connections or some devices which require a cable. They do not work over Wi-Fi, and those still can be connected to the switch we have. So it will drastically reduce the hardware footprint and make your company or your office more sustainable with the resources we have. Secondly, you unify the connectivity to a single connection technology for the user. And this, as I already told you before, will help the user, especially when talking about Wi-Fi. Everyone at home has home Wi-Fi. So they already know how it works with a phone to connect to a Wi-Fi. They know how to get to the Wi-Fi settings. They know they are expected to put put a password in there. Maybe for a company Wi-Fi you put in username and password, but this is still something manageable. But it will be one connection type, which they are already familiar with from home, making it easier for them to understand how connections are working. Of course, if you have like pre-cabled workstations with a fixed desktop PC with a cable in there, they even have to do less. But when moving to an open space concept, enterprises are handing out more and more laptops to their employees, so they are able to sit wherever they are. There's a free spot in the office, and you cannot achieve this with putting desktop PCs on every of those open space single workstations or work spots. So you will gonna need laptops, and those should be connected to Wi-Fi. Thirdly, this approach allows you full flexibility and scalability of office networks, as you can just add or remove access points as needed. because your switch will most likely never be your bottleneck anymore. If you have one, maybe 48 port switch, per floor, you maybe have 15 to 20 access points per floor. 20 is probably even already too much. Maybe let's say 15 on the floor, and then you have 10, 12 devices which you need to cable because they are not Wi-Fi compatible. Then you already have, or you still have so many ports left to cable new use cases. You can cable new access points, and you can save actually power on this one. However, I want to get into the power consumption part just next, because this is neither an advantage nor a disadvantage for mobile first, because we need to talk about energy efficiency between wireless and wired technologies. Wireless not necessarily is more efficient than wired connections, because an access point will need more power per user than you would have with a switch. So if you directly compare, okay, let's say how much is the power consumption of one switch to, let's say, 6 or 8 or 10 access points, the switch will win. The switch needs less power to do it. However, this is just half of the story. This is just if you compare it directly with each other, which is not realistic, right? Because your company or the enterprises are already providing a Wi-Fi network. So the comparison should be, how many switches can I reduce from using Wi-Fi coverage instead of wired coverage, and how many more access points do I need to achieve this? And this kind of trade-off, like how many switches do I get rid of and how many access points do I need to? This is the kind of comparison you need to run, which is more truthful and honest in a comparison. But it is very specific to the enterprises you are in or you are running. So it is neither an advantage nor a disadvantage. Probably it will break even at some point. And you will not be saving a lot of power and energy. I still believe, as based on, I did a calculation on my company, it will save power, but on a yearly basis seen, it's not much, but it's something. Okay, let's move over to the disadvantages. This is one thing which did not change in the past years. It's something which Wi-Fi and cellular could not get rid of and probably will never get rid of, which is interference. So interference in wireless networks, my classic example is here, a microwave versus a 2.4 gigahertz Wi-Fi band. Yeah, the microwave wins. So whenever you are running a 2.4 gig Wi-Fi, 2.4 gigahertz Wi-Fi, and you turn on the microwave, you will have no coverage around the microwave because they are using the same frequencies. And this kind of interference just barely exists in wired networks. You will see some kind of, or you can see some interference on cable networks if you're running a lot of copper cables which are not well or properly shielded in a huge bunch, like talking about this size of a bundle. For example, in data centers, you might see some interference, but yeah, this is actually negligible, especially from the user to network perspective. So yeah, this is definitely a disadvantage. And secondly, another disadvantage is troubleshooting is more difficult for wireless networks, because for wired networks you can troubleshoot the port on the switch, you can troubleshoot the cable, you can troubleshoot your end device, but for wireless it's definitely harder to find the issue between the user and the network, because you have an access point which works for, let's say, 17 users, but one user complains about connection dropping, connection performance issues. So why does it work for 17 but not for the 18th person? So there's where the analytics function, which I recommended in the beginning, is going to support you to find those kind of issues, but the troubleshooting will be more difficult on wireless networks for administrators and engineers. Okay, let's summarize the past 30 minutes pretty much. As mobile first is a great new architecture which should be receive definitely more attention on the market and in the industry, as this really can help enterprises to move forward with changing office concepts, with changing or reducing the hardware footprint, becoming more sustainable, at the same time becoming more flexible and scalable, and maybe adopting new cloud usages for like controllers and analytics functions. My colleagues and me also published a white paper on this mobile first architecture, which I will link you in the video description. So if you want to get a deeper look into the mobile first architecture, the architectural approaches, and a little more details about the use cases, advantages and disadvantages, feel free to go there and download the white paper and read through it. And yeah, let me know what you think. What is your personal take on mobile first? Do you think this can actually be a good new way of working? Or do you think like, okay, I don't trust Wi-Fi. It just breaks up for me whenever I work on it. Let me know what you think. And I hope to see you in the next video. Cheers. Bye-bye.